Hi, in this tutorial we'll look briefly at some of the defensive programming techniques in D. More specifically, we'll be looking at code contracts, or design by contract as it's called in D. So design by contract allows you to specify a state that must be true when a function is entered, and conditions that must be true when a function has run. So we'll start at the top here and we'll see our read input. Read input itself should specify that the min value has to be lower than the max value. We are already enforcing this when we handle the arguments by calling the validate function, but we might introduce a bug later on that will not call the validation or something else, so we want to specify it here too. So the basic syntax is the in keyword, then a block, and when you use contracts you also have to specify the keyword body for the main function. So we'll say that the min value have to be less than the max value, and this code is run every time we call read input. This code is called first. In other programming languages you normally add it at the top of the function, but D supports this. And when you compile in release mode, all code contracts will be removed. So even if you have code calling something else than only asserts, the entire contract will be removed. Then we have our handle arguments function, and this function doesn't return a value, but it does modify the settings, and we need to make sure that the function has actually modified the settings and are creating a setting struct that is valid. And we know that this function will exit the program, so we might specify that whenever the function is run, the settings should be invalid if it returns. And you see the result symbol here, and this is bound to the return value of handle arguments. So if we had the return value, then we could have some symbol that is bound to that return value, and we could check that the return value is valid. We don't have a return value here, so we'll just do it like this, and we'll say that settings validate length should be equals to 0. If you also had an in contract, it would look like this. So you have in and then an out and then the body. Next off, we are down in the main function, and we know that handle arguments will be enforcing the correct behavior, but handle arguments could be some function made by a third-party library or something. So it doesn't harm to specify before we run all this code that it should also be a valid settings. And we might also move this up to a different function, so we can take we can take the settings and we can run the game from a different function, and we can specify that settings validate length should be 0. So we should return or run game with our settings. And you notice up here that I specify that it's a const reference. And const, as always, means that I am not going to change this setting struct any values that are visible through this struct. So let's try to run this. And we see an error. It's the mutable method validate is not callable using a const object. And that's because we here specify that we take a constant object. We are not going to change it, but then we call the settings validate function. And this is not specified as const, so this one might actually change some of these values. So we also specify const on the validate method, and that way we are enforcing that we won't change anything in here. So if we try to change anything, cannot modify const expression this.min. And we try to run it, and looks like it's working. And running the application works, but I just discovered a bug in our code, and this is because I have been building in release mode, and this is not a good thing because release mode will remove all the code contracts. So I haven't been seeing the assertions that were happening. So we have a bug here. We see in line 80 we have an assertion failure. And if we go to line 80, we see one of these. So this has been failing. And this is because the getOpt module doesn't return the long options or the short option. Let's see what it returns. It returns the string we added to the option specifier. So let's fix our code here. For age. And the same up in our answer or the short option. And now it looks like it's working. So let's return to our validate function here. We specified that it should not be able to modify any of its variables, but we can also specify that it won't be able to change any global variables, and that it cannot call code that modifies some global variables or use some global variables. So we cannot call writeLine from this function now, but specifying that it is pure is a very good thing, because the compiler can optimize this to not call it more than necessary. And we can also specify the no throw, because this code should never be able to throw. And if we try to throw some code, then we would get an error saying that we cannot throw from this function. Is no throw yet may throw. You might be tempted to use immutable instead, and it is possible to use immutable, but immutable is very strict, as I've said earlier, so immutable methods can only be called on immutable references. So in order to call an immutable method, the entire struct has to be immutable. So it's difficult to be able to use immutable, and but const is very good to put on functions. We can also look back at read input. We have our in contract, but let's also add an out contract, because this one returns an integer, but that an integer can be a whole range of the 32 bits. So we would like to enforce that it's actually within the bounds of the min and max value we stated. So assert that results is greater than or equals to min, and that it's less than or equals to max. So if we make a fix in this function some time in the future, and we introduce a bug where the result is returning a value outside the range, we will get an assertion error. So we have added a couple of extra assertions by using the sign by contract in D, and every function that is able to use code contracts should be using code contracts. This greatly helps when you are refactoring code and extending the code later on, so it will check that your old logic still holds true, that you suddenly ain't invalidating something that is expected to be true in your existing code. And you have to remember always that these are compiled out in release mode, so you cannot use it to enforce user input, for instance. Then you have to use runtime features that is also available in release mode. We'll probably get into that later on. So thanks for watching. Bye.